Okay, we'll get started here. Welcome, everyone. This talk is Improve Your ML Projects, Embrace Reproducibility and Production Readiness with Kedro by Juliana Ferreira Alves. I hope I got that right. If we have time at the end, we'll take questions, but if not, you can reach out to her after the presentation. So, thank you.
Thank you. Well, hello everybody. My name is Juliana, and I'm very happy to be here. My talk is going to be Improve Your Machine Learning Projects, Embrace Reproducibility, and Production Readiness with Kedro. First of all, introducing myself, my name is Juliana Ferreira Alves. I'm a Brazilian woman from the data science. I started my career as researching machine learning algorithms to apply on Alzheimer's disease diagnosis, but I'm currently working in the finance field. I'm also a pilates, was thanks to pilates that I started in the tech career. And right now, I'm also a mentor, so you can reach out to me if you have questions on how to start in tech or data science. I have a bachelor in computer engineer, and I couldn't forget to add my passions here. So I'm an avid traveler. I love to travel. So these conferences are not only for my brain, but also for my soul. I get so happy to go and meet new places and new people. It's very, very good for me. And my passions also include dancing, music, and food. Well, our agenda for today is going to include talking about what is Kedro, what are the cases of use, and go through the Kedro's core concepts. So first of all, what is Kedro? Kedro is a Python framework for creating scalable data science pipelines. It's utilized to use software engineering best practice for production-ready data science code. And what that means, when you think about a data science project, you can think there's a data scientist, a machine learning engineer, data engineer, all in the same team, having to talk the same language. And sometimes it's hard to translate between those languages because the data scientists know a lot about modeling, statistics, experimentation, but don't go how is the production side of it. While the machine learning engineer know how to put things into production, but needs to go to the translation task of reading through all the code of the data scientist and having that into production. So Kedro was created by Quantum Black from McKinsey in order to understand how that works and make it easier for all the team members to communicate and make it a framework to easily integrate all the process. So the data scientists understand how that's going to go in the end for the production, and the people working with putting the code into production, the data engineers and the machine learning engineers, understand how to easily get the information from the code. But you might be thinking, so Kedro is going to solve all my problems? Well, it's going to solve a lot of your problems, but you might need to still use some other tools to help you to finish your whole pipelines. So you should think of Kedro as a data science, machine learning, engineering pipeline framework. But when we talk about orchestrator, you might think about other libraries. But the good part is Kedro has a lot of connectors, so it's going to be easy to connect to your pipelines and your functions into orchestrated systems. Also, you shouldn't look at Kedro as a machine learning ops framework in the way of I'm going to put into production and it's going to be always getting my data. You need other libraries to do that for you, and neither for a replacement for data infrastructure. It does have connectors that's going to help you to ingest your data from a lot of sources and to load data in other sources, but you shouldn't think of it as a replacement for your data infrastructure. And what is Kedro main features? So now we're going to go through what Kedro has to offer when you need of how to think of your projects. it's going to provide you a project template, a data catalog that's going to make it easier for everybody to know which data you're using or creating. It's going to introduce the concepts of nodes and pipelines. You're going to make it easier for you to do experiment tracking, and also have an extensibility feature for you to, like I said, connect with data infrastructures or to orchestrate your pipelines. First of all, we're going to go deep into a feature. What is the project template? So Kedro have this project template, which is a directory structure that's going to help you on how to build your project to give to somebody. Because sometimes you start learning data science, and you think, OK, I have my notebook, I have my experimentation, I find a good model. What I'm going to do with that? How am I going to present that to other people in my teams, to the software engineers, to the machine learning engineers? So to make it easier, it gives you the template, so you don't need to put thoughts into it. It can just use it. So in this way, the project template give these folders and files that help you on facilitate all this information. Initially, when you create a Kedro project, it's going to have this git ignore that's going to put your, it's going to make the version control don't get your data or credentials. Also have the conf file, the conf folder, which is the configuration folder. In this folder, you're going to have the data catalog that I'm going to talk next, but also all the configuration of your machine learning models can be there, and it can be easy changed if you want. And as you can see, you have the base, which is the default environment, and later it has the local, which is the environment that doesn't go to the version control. The local folder, it's so overscribe. It goes over the base folder. So if you have things you want to run in your computer, in your machine, but you don't want that to go to your GitHub, that's where you're going to put the information on a conf file. And you can also create other environments, such as the dev, the production environments, out there, and then specify later so Kedro can get the right environment. It also creates the data folder, which is going to have, it break down all the kind of data you might use in your project. Usually, you just start with the raw, is the data you're first starting. And then you have all the other folders, which is things you're going to upload there, you're going to load there from your model. So you have the intermediate data that you might need to use later, and it's going to be easy to access there. You can have the features you use, the models, and this super cool one is the reporting one that we're going to see also in the experiment tracking. Later on, we have the docs, the notebooks. The notebooks you should use for when you're first starting with your project. So you don't want to start thinking already in Kedro, design and everything. You want to do some experimentation in a notebook, and when you start, you have a moment, starting point of your model, then you put it to Kedro, because starting thinking and designing to Kedro can be challenging. So the idea here is you start in a notebook, and first you have a pilot, you go into, you translate that to Kedro, and you can keep changing that easier. You also have the pipeproject.tom, that is where Kedro understands where to get the information of configurations file. And also you have a README and a source. The source folder is where all your code of pipelines and nodes are going to be stored. That means when you think about your notebook that you created, and you have the pipelines, and you have all the sequence of things you're going to do, that's where you're going to translate that code and the pipeline. I'm going to go deep into that later, but it's just to give a heads up. And also, we can put the test files in the source folder, and we have the run.python, which is the file that's going to make Kedro understand which pipeline is going to run. OK, and now let's go to data catalog. Like I said, we have the configuration folder, and one of the cool things of Kedro, you just specify where your data is, and it manages to get the data for you. So for example, in this simple example, I'm just getting local data. So as you can see, I'm getting a CSV file, and they're all local. And so I'm getting the raw file in the first two data, the genetic data and the phenotypic values. And after that, after manipulating that data, I'm going to create the training and the test data. And I don't have them yet, but I need to specify on the data catalog so it understands when I run that pipeline, it's going to add to that folder, which is the intermediate folder. So you just specify, and Kedro takes care for you. But you don't need to only use local files. It has a lot of connectors. So besides the local files, you can use Hadoop file systems. You can use Amazon S3, any S3 compatible storage. So if you have a kind of the MinIO kind of storage file to try to make an example of your database would be, you can just use here and put into production to make a test. You also have the GCP, Azure, and you can also get it straight from HTTP. Okay, but I'm here talking about pipeline and nodes. Let's get deep on what are those. For those that are used to data science, data engineering, a pipeline is pretty straightforward. But for those that are new to this world, a pipeline is just a set of actions to manipulate your data. And a pipeline is going to organize the dependencies of all your code, all the nodes that are inside it. So the pipeline is an object in Kedro that you call, and you say how many nodes and how they're going to be run inside. So you can have, in the end, all the kind of data functions you need. To be better to understand, I have this example. I don't know if it's easy to read there, but it's an example where I'm just creating creating a pipeline, which returns the pipeline object that I mentioned. And then I have the 3 nodes there. Those nodes you can think about just steps I'm processing data. And the easier part is because I just say which function it is and say what is my input and output. And in a name, I just say, I name how the node's going to be. So later on, if something breaks, if I get some error, I'm going to say which node it's going to be the problem. And also a node. The node is each function. You can, to simplify, you can just think is a wrapper for a function inside your pipeline. And it's just you just need this wrapper because you need that to have your inputs and outputs specify, which is going to come from the conf file. And here, another example of how a node works. It was in the previous slide, the coding slide, where I have the node. But as you can see, it's just a function. I made a function and I wrap it with a node object and pass what are the inputs, the outputs, and what is the name, like I showed before. 1 minute. And now we're going to dive in what is the experiment tracking. So experiment tracking in Kedro makes it easier for you to understand how are your models performing. You have your models, and you change some parameters, or you change your files, and you want to see how that's going to change the overall metrics. The experiment tracking is going to make it easy to log because it's automatically log your parameters, metrics, and even mod artifacts during a pipeline run. So when you run, you run Kedro run. Also, it storages your metrics in a JSON or a YML kind of file. And helps also with visualization. So it has a feature, which is Kedro Vis, where you can just run and see how was your metrics during the time, during the runs, how did it perform. And I have a little demo here of how it works. So when you run Kedro Vis, you're gonna have this visualization here, which will show you how is your pipeline. And also, you can click, you can see the databases, you can see the pipelines. When you go and expand, you can see all the functions. But the part here that I want to show is the metrics. So each one of those are one runtime, and you can compare how the runtime worked. And here, you can easily see how the metric change over the time, and for each metric, you can have a different plot. So for this reason, it's easy for somebody that is just wants to make an experimentation to see how that's gonna work in the end. And you can also add some plots as your metrics and also store there. So it's very easy to talk into the business people, with somebody that is not into data science, to explain what is going on over the time when you're changing your metrics and everything. Another very good feature from Kedro is that it has extensibility. So you can connect with commercial machine learning platforms as well as open source orchestrators. So you basically can connect to get data or orchestrate your pipelines very easily, and the community that is maintaining Kedro is highly active to create new connectors every time is needed. So that's a big plus for those that want something easy to start and to keep deploying. So the main point here in this talk is Kedro can help not only you, data scientists, to understand how the whole production system work, but also who are not in data science don't need to go deeper on the statistics or how the experimentation happens to understand what's going on. Is to facilitate the communication between the team members. Also, the reproducibility ensures you can easily send your project to other team member, and it can run in their machine with having much problem. You can get the requirements. It's also easily make a Docker file and make it easy to send to anybody. And for scalability, it's also easier to, when you start thinking your project's getting bigger, you need to run different kind of algorithms in machine learning, or you need to get different type of data, and you need to compare those. When you're working on a notebook, it kind of starts getting overwhelming. So when you have a library like this, it makes it easier to just compare which algorithm perform better and which parameters are you using. Because when you start using Kedro from the beginning, you can see how the parameters were changing every time you run one time. And I also wanted to conclude this talk by saying this quote from the Clean Code book, which is, clean code always looks like it was written by someone who cares. So I think that's the main point here, is you know what your model does, and you want it to be easy for other people to understand it too. You want them to see what was the work you put on it. So that's why is it about. It's to improve readability and improve the other aspects of development. And thank you for attending this talk. This is my QR code. So if you want to connect or just chat, you can scan this QR code. And I think we're going to have a few time for questions if somebody have any questions.
Do we have another microphone? Oh, okay. Questions? I'll run the microphone to you. All right. And then you hand it off to her.
Yeah, sure. Thank you so much for your talk. I was wondering, once you have a trained model and you're ready to do inference, are there any tools for setting up an inference pipeline with this?
Yes, you can do. Like you're making a notebook, you can have the test. You can have a pipeline just for testing or just for predicting. And then you can, when you make your executable file, it's just preferable that's going to be like in an S3, in a cloud kind of environment. So you can just update, and it's going to make your prediction, your inferences, each time you run it.
Cool, thank you.
You're welcome.
Hi, thank you for your talk. I was wondering where we would find your sites. Are they going to, should I just go to the Kedro website and get the content from there?
Most of the content was from Kedro documentation. They're also releasing some videos on YouTube that is pretty straightforward. I can put this code on GitHub. I didn't put it there because it's very simple, a case of use. But the documentation has a lot of examples on how to go, even a get started kit, where you can, in a few hours, make a little first project.
Any other questions? Okay, thank you so much.
You're welcome.